All right, so today we're doing Chapter 6, Section 3, Properties of Trigonometric Functions. So yesterday we worked on the exact values and started kind of operations with trig. And then today we're going to look at properties. Our first learning objective is to determine the domain and the range of trigonometric functions. So from yesterday, if you remember, sine is y, cosine is x, tangent is y over x, and then cosecant, secant, and cotangent are the reciprocals of each of those. And this is for a unit circle. The domain for a sine function is all real numbers, and the domain of the cosine function is all real numbers. What? So domain, you can input any real number into the sine function and into the cosine function. Any number is on the table. The domain of the tangent function is a set of all real numbers except when we have pi over 2 or 90 degrees or any multiple thereof. So what do I get when I multiply pi over 2 by 3? 3 pi over 2 because it's odd multiples. What do I get when I multiply pi over 2 by 5? 5 pi over 2. So any odd multiples of pi over 2 are not allowed to input into tangent because those are undefined values. It's when the denominator, the x value, is 0, so we can't have the x value being 0. The domain of the secant function, so remember secant is the reciprocal of the cosine. So cosine is 0 at 90 degrees, and you can't have 1 over 0. So that leaves secant function cannot have odd multiples of pi over 2. So both secant and tangent can't be pi over 2 or odd multiples thereof. Cotangent, if the domain of the cotangent function is a set of all real numbers except integer multiples of pi. So it's where your y coordinate equals 0, and that is pi or all integer multiples of pi. Pi, 2 pi, 3 pi, 4 pi. So in this case, it's not the odd multiples, it's all multiples. And the domain of the cosecant function is the same as cotangent. It can't be integer multiples of pi. So pi, 2 pi, 3 pi, 4 pi, all those are off the table for cosecant. So guess what happens on the graph at those places where the domain is undefined and can't be? What happens on a graph when that point isn't in the domain of the function? Is it? What do we know about graphs? If I know I can't equal like 1 over x, think about what the graph of 1 over x looks like. What happens as that function approaches 0? Where you can't, because we can't equal 0. It's an asymptote. So all these places that are definite no's in our domain, there's going to be an asymptote. So for tangent at pi over 2, so it's going to come up and then approach infinity of pi over 2. So it's going to have an asymptote every odd multiple of pi over 2. So it's going to we get some crazy functions up in here with all those asymptotes. So the output, so these are our range values. Sine and cosine never go below -1, and they never go above 1. The outputs are never smaller than -1 or bigger than 1. Cosecant is always going to be less than or equal to -1 or greater than or equal to 1. Because remember, it's the reciprocal. So it gives you the opposite. Secant is going to be less than or equal to -1 or greater than or equal to 1. And tangent, whatever, tangent, cotangent, they could give you out anything. They go all the way to -infinity and all the way up to regular infinity. So the output of tan and cotangent could be anything. Okay, so putting these in a table looks like this. So I would definitely box this or highlight this so that when you're looking to answer that question on your homework about domain and ranges, your eyeball grabs onto this quickly. All right, so now we're going to start picking apart our trig functions. Our trig functions are cyclical. They repeat over and over and over again. So when we look at the period of a trig function, where you're asking yourself, how long does it go until it repeats itself? So how far around the circle do you go before you start over again? What is it normally? How far around is 360, or in radians it's 2 pi, right? So we can fuss with a function that will speed up that rotation or slow down the rotation. So we're going to look at the period of a trig function. All right, so if I look at my little angle pi over 3, we know that its coordinate that matches up to pi over 3 is 1/2 and √3 over 2. So if I want to get back to pi over 3, I'm going to add 2 pi to it. So that's going to get me through one complete cycle of my trig function. And you can do that with any angle. Any angle, when I add 2 pi, will get me all the way around the circle and back to where we were originally. So we write that as any, where k is an integer, if I add 2 pi or any integer multiple of 2 pi to my sine function, I'm going to get out the value of whatever that original angle is going to be. So the sine of 3 pi, or the sine of pi over 3 is the same as, the answer is going to be this, equal to the same thing as the sine of pi over 3 plus 2 pi. Same with cosine. So a function f is called periodic if there's a positive number p such that whenever theta is in the domain of f, so is theta plus p. And f of theta plus p is equal to f of theta. If there is a smallest such number p, this smallest value is called the fundamental period of f. So it tells you it's how long it takes to cycle through. And for a unit circle, that's definitely going to be 2 pi. All right, so here are the periodic properties. If I add 2 pi to sine, cosine, cosecant, or secant, the angles of those, it's going to be equal to the original function with the original theta. Tangent and cotangent cycle every pi. So their period is pi. The sine, cosine, and their cofunctions are 2 pi. So if you want to make a note, circle, say, oh, tan cotan is pi and not 2 pi. Just to mental note that. All right, so we're going to find exact values of some wonky looking trig functions, but we're going to subtract out the multiples of 2 pi for sine or cosine and the multiples of pi for the tangent to find out which original angle we're actually looking at. Okay, so 17 pi over 4. You want to look at that. I know it's some multiple of pi over 4. Is it an odd integer multiple? So there's no magic here. Pi over 4 is sitting right there in front of us. We know that's our original angle. 17 pi over 4 just means that it is 17 times that. So using the property, we can say, since 17 pi over 4 is an odd multiple of pi over 4, we can just find the sine of pi over 4, and that's the same answer. It is actually pi over 4 plus 4 pi. And since the sine of 4 pi is root 2 over 2, that is the answer to sine of 17 pi over 4. All right, so when we look at 5 pi, I know 2 pi is 2 times around the circle, or 2 pi is 1 time around the circle, and then another 2 pi to give me 4 pi is another time around the circle, and then I have 1 more pi will get me halfway around the circle. So 5 pi is the same as 4 pi plus pi, which is the same as cosine of pi, which is equal to -1, because we're on the quadrant. Our y coordinate our x coordinate at 180, because pi is the same as 180. Our x coordinate at 180 is -1. That's why the cosine is -1. All right, so let's look at 5 pi over 4. We're taking a look at the tangent. 5 pi over 4 is the same as pi over 4 plus 4 pi over 4. 4 pi over 4 is the same as pi. So we know tangent cycles in pi. So if I add a pi to it, it's the same as the tangent of pi over 4. We know tangent of pi over 4, that's 45 degrees. Tangent of pi over 4 is 1. So the tangent of 5 pi over 4 is also 1. All right. And that happens because we're in the third quadrant, and the x coordinate and the y coordinate are negative. Negative divided by a negative gives you a positive. Okay. Signs of the trigonometric function in a given quadrant. What? We were just talking about that. All right. So, if you are in quadrant 4, this quadrant right here, your x is going to be positive and your y is going to be negative. So if x is positive and y is negative, that would mean my cosine is going to be positive, my sine is going to be negative, my tangent is, because I have 1 positive, 1 negative, my tangent is going to be negative. And then their cofunctions follow the same suit. So because my y coordinate is negative, my cosecant is going to be negative. Because my x coordinate is positive, my secant is going to be positive. And because tan is negative, cotangent is also going to be negative. So this little table, if I'm in quadrant 1, sine and cosecant is positive, cosine and secant is positive, and the tan is positive. So you can think of this as the y's, the x's, and the tangent is a combination of the y and the x. In quadrant 2, y's are positive, x's are negative, so the combination of the two is going to be negative. Quadrant 3, y's are negative, x's are negative, so the sine and cosine are going to be negative. And when I combine those together to get tan, it's going to give me a negative and a negative for a positive. Quadrant 4, y is a negative value, x is a positive value, so sine and cosine are going to be negative and positive. When I put those together, tan is also going to be negative. All right. All right, so if sine of theta is greater than 0, cosine theta is less than 0, name the quadrant in which angle theta lies. So if sine is greater than 0, we can be in quadrant 1 or 2. If cosine of theta is less than 0, we can be in quadrant 2 or 3. The one that overlaps is quadrant 2. So it must be quadrant 2. Easy peasy. Fourth objective, find the values of the trigonometric functions using fundamental identities. Ooh, fundamental identities. Okay, so our reciprocal identities is something we've been talking about, but now we're going to actually pen to paper it. Cosecant of theta is 1 over sine theta. Secant theta is 1 over cosine theta. And cotangent theta is 1 over tan theta. So we can say, and these are, please highlight this right here. This is something we've been talking about and mentioning prior, but this is kind of new to us. The tangent of theta is the sine theta over cosine theta. The cotangent theta is cosine over sine theta. So we're going to find exact values using identities when sine and cosine are given. Sine of theta is root 10 over 10. Cosine theta is 3 root 10 over 10. Find the value of each of the 4 remaining trig functions of theta. So the 4 remaining would be tan, cosecant, secant, and cotangent. So to find the tangent, we take the sine theta over cosine theta, and we have to be really good. Remember, multiplying or dividing by a fraction is multiplying by the reciprocal. Remember when we did that in 5th grade and we were like, I don't know how to even hate this. Hello, pre-calculus, 5 years later, you guys finally are. We did it, we made it, we're here. So we multiply by 10 over 3 root 10, and we get 1/3. And then now we do the reciprocals. Reciprocal of 1/3 is 1 over 1/3, or 3. The reciprocal of root 10 over 10 is 1 over root 10 over 10, or 10 over root 10. You multiply the top and the bottom by root 10, and you get root 10. The secant is 1 over the cosine, which is just the reciprocal of 3 root 10 over 10, which is 10 over 3 root 10. Can't have root 10 on the bottom, so we multiply the top and the bottom by root 10. Simplify that down, and we get root 10 over 3. Take a moment and make sure you can do this simplification, multiplying by root 10 and then simplifying it down to root 10 over 3. If you cannot, let me know and I can walk through that with you. All right. We know the equation of a circle, because remember all the way those times back to semester 1 when we did the equation of a circle, it's x squared plus y squared equals 1. That's the equation of a circle centered on the origin, radius of 1. We know that y is equal to sine theta and x is equal to cosine theta. So we're going to substitute those into this equation of a circle. So we can say, and make a note, this is the first time we're seeing this, when we have a squared, when our entire trig function is squared, we put the exponent next to the trig function, because we don't want to confuse people and have them think we're squaring the angle. We're not squaring the angle, we're squaring the entire function. So we put this exponent onto the function. Crazy, right? But it keeps us from being confused about where that square is going. It says we're going to take the sine of theta, then square it. So the sine squared theta plus cosine squared theta is always going to be equal to 1. Star, highlight, box the heck out of this. This trig identity doesn't go away. It is like a virus. It stays in your system forever. You don't get rid of it. You just build an immunity and you give it to everybody else. So, yay. Makes a good bacteria virus immunity. Okay, so if we manipulate the previous function, we get sine squared theta over cosine squared theta plus 1 equals 1 over cosine squared theta. And all we've done is we've taken each of these and divided it by cosine squared theta. So I get sine squared theta over cosine squared theta, cosine squared theta over cosine squared theta, and 1 over cosine squared theta. So I've divided each item by cosine squared theta. What do we know sine squared theta over cosine squared theta is equal to? What's sine over cosine? Y over x. It's a tangent, yeah. So sine squared theta over cosine squared theta is tangent squared theta. 1 over the cosine is secant, so 1 over cosine squared is secant squared. This part, not as important. This is just how we get to here. But highlight them, star, smiley face. Tan squared theta plus 1 equals secant squared theta. The reverse is also true. If I divided everything by sine squared theta, I would get this property right here. Cotangent squared theta plus 1 equals cosecant squared theta. Same thing. Highlight, box, star, whatever y'all gotta do. All right, so here's your fundamental identities. If you are out in the wilderness by yourself and you need these fundamental identities, I know you're going to have your pre-calculus book with you, because that's what I would take if I was in the wilderness by myself. All these properties are on the back binding in your textbook. Quick reference. So if you get lost in the wilderness and you need these functions, they are all on the very back of your pre-calculus book. All right, so let's use these. We want to find the exact value of each expression. We're not going to use the calculator. So we have 1 over cosecant squared 35 degrees plus cosine squared 35 degrees. Let's see how we manipulate that. We know that cosecant is equal to 1 over the sine. So we're going to go 1, we're going to replace this with 1 over sine squared 35. And we get, so even though we don't know the exact value of 35, cosine 35, we don't need it, because this will become sine squared 35 plus cosine squared 35, and we know, because of the property, that that will always equal 1. So it doesn't matter what the theta is, sine squared plus cosine squared is going to equal 1. All right, so let's take a look at this. Cosine over sine, we know is cotangent. We wrote that property down. So we have cotangent of pi over 3 minus cotangent of pi over 3. That is equal to 0. So we're going to find the exact values of trigonometric functions of an angle given one of the functions and the quadrant of the angle. Ooh, this is exciting. It's like detectives. So we know that sine theta is equal to 2 over 5. Cosine theta is less than 0. Find the exact value of the 5 remaining trig functions of theta. So since sine theta, 2 over 5 is greater than 0, cosine theta is less than 0, we must be in quadrant 3. X is negative, y is positive, quadrant 2. So we must be in quadrant 2. So we know that our radius is 5 and our y value is 2. We're going to use a little Pythagorean theorem. X squared plus y squared equals 5 squared, or the equation of the circle. And we know that y value is 2. The radius is 5. So we are going to go 25 minus 4 to get 21. And that our x squared is equal to 21. That leaves our x as negative root 21. Why is x not positive root 21? The reason we have to use negative root 21 is that we are in quadrant 2. So our x coordinate has to be negative. And it's true, negative root 21 times negative root 21 gives us positive 21. So we have to discard the positive root 21 as not a possible answer. So when we put the other trig functions together, cosine of theta is x over r, x is negative root 21, r is 5. We put together the tangent. Tangent theta is y over x, y is 2, x is negative root 21. I'm going to multiply the top and the bottom by root 21, and we get 2 root 21 over 21 negative. And then cosecant, secant, and cotangent are just the reciprocals of their cofunctions. Make sure you're rationalizing the denominator. Okay. Given that sine theta equals 2 over 5 and theta is an acute angle, so which quadrant has all the acute angles in it? Quadrant 1. Find the exact value of the remaining 5 trig functions. So we know sine squared theta plus cosine squared theta equals 1. We know sine theta is 2 over 5. So if we square that, we can solve for cosine squared. So we subtract 4 25ths from both sides, and we get 21 25ths. And we get cosine is equal to negative 21 25ths, but solution 2. So they are, okay, so they're solving the problem from the previous one. All right, let me go back. So they're taking this problem again and solving it in a different way. So theta is an acute, thinking about theta as an acute angle from 180 degrees. Does that make sense? If you're, because you're in quadrant 2, we're thinking of this, we're finding the exact values. This is solution 2. So we're finding the same, we're starting with the same problem here. So we're starting with this problem. So if we start with this problem, where sine theta equals 2 over 5, cosine theta is less than 0, now we're going to find the remaining. So given that theta is 2 over 5. Theta is an acute angle. We're going to use the sine squared plus cosine squared equals 1. So if we take sine, we know sine is 2 over 5. We're going to square it to get 4 over 25, and then subtract that from 1 to get cosine squared equals 21 over 25. Then we take the square root of both sides. And because we know cosine is less than 0, we say that the answer, we have to take the negative answer to when we square root 21/25. That's where the negative comes from.
Now, how do we know in this question that it's, or that the cosine is a negative?
It tells us, so we're just taking the original problem from the slide before. It gives us that. So it, right here, it tells us cosine is less than 0.
It just didn't say it in the second part.
Right, because it's saying find your, this is solution 1 using the circle. And the next one is going to be, start with the same problem, use identities. Since theta is in quadrant 2, x values are negative, and it tells us that tan is sine over cosine, cotangent is the reciprocal of tan, cosecant is the reciprocal of sine, and secant is the reciprocal of cosine. All right, finding the values of the trig functions of theta when the value of one function is known and the quadrant of theta is known. Given the value of one trigonometric function and the quadrant in which theta lies, the exact values of each of the remaining 5 trigonometric functions can be found in either of 2 ways. Using a circle of radius r, so you can draw a circle and showing the location of your angle and a point that corresponds to the angle. The radius of the circle is square root x squared plus y squared. Assign a value to 2 of the 3 variables, x, y, and r, based on the value of the given trigonometric function and the location of p. If you're given sine, you know what the y-coordinate is and the radius. If you're given cosine, you know what the x-coordinate is and the radius, and you can find the y. Use the fact that p lies on the circle to find the value of the missing variable. Apply the theorem on page 374 to find the values of the remaining trig functions. Or, use appropriately selected identities to find the value of each remaining trig function. I personally like this one better because my brain is more familiar with using Pythagorean theorem and the equation of a circle than it is with the trig identities. Either one will give you the correct answer. All right, so we're going to use the circle, given that cotangent is 1 over 3, sine is less than 0, and we're going to find the exact value. So if cotangent is greater than 0, sine is less than 0, we go to that table that we had, and we see we are in quadrant 3. Because remember, a negative and a negative will give you a positive. So negative x value, negative y value will give you a positive cotangent. So we're down here in quadrant 3. This tells us this is x over y. So our x coordinate is -1 and our y coordinate is -3. Okay, so we know that x and y are -1 and -3. So I'm going to use the property r squared equals x squared plus y squared to find the radius of the circle. So negative 1 squared is 1. Negative 3 squared is 9. 1 plus 9 is 10. So the radius is equal to square root of 10. Our tangent is the reciprocal of our cotangent. So it is 3 over 1, or 3. Our cosine is x over the radius, so that's negative 1 over root 10. We multiply that by root 10 over root 10 to get negative root 10 over 10. Our cosecant is r over y, so that's negative root 10 over 3. Our secant is r over x, root 10 over negative 1, or just negative root 10. And our sine is y over r, which is negative 3 over root 10. Multiply that by root 10 over root 10, I get 3 root 10 over 10. Make sure here y values, since the y value is negative, this makes my entire sine negative. All right, so second solution, so we're going to use the identity instead of the circle property. So we're going to use cotangent squared plus 1 equals cosecant squared, which means 1/3 squared plus 1 equals cosecant squared theta, which is 1/9 plus 1 equals cosecant squared theta. So our 10 over 9, we're going to take the square root of that. And we are going to keep the negative value since we are in quadrant 3. Sine, cosine, secant, and cosecant are all going to be negative in quadrant 3. So then we have negative root 10 over 3. And we know that the sine is the reciprocal of that. So we can piece together the tan is 1 over the cotangent. Cosine, that's an interesting way to look at it, is sine over tangent. And secant is 1 over the cosine. All right, so even odd properties. Sine of negative theta is equal to negative sine theta. Cosine of negative theta is equal to cosine theta. Tangent of negative theta equals negative tan theta. So if you look, sine is an odd function. When I input a negative theta, I get out the negative sine theta. Cosine is an even function. When I put in a negative theta, I just get out theta. Tan is an odd function. And then their cofunctions follow suit. Since 1 over the sine is the cosecant, cosecant is also an odd function. So put a little star next to these properties. We will use them sometimes. Not as frequently as sine squared plus cosine squared. So using those properties, we're going to find the exact value of cosine negative 60 degrees. That is the same, because cosine is an even function, that's the same as a cosine 60 degrees, which is equal to 1/2. Sine of negative 390. Sine of negative 390 is equal to the negative sine of 390. 390 is 30 plus 360, which is equal to negative sine 30. And then the sine of 30 is root 3 over 2, so that's equal to negative root 3 over 2. All right, so then we have our last one, which is tan. 37 pi over 4, which one is the original function for this guy? Pi over 4? Right, it's pi over 4. So tan of negative 37 pi over 4 is negative tan 37 pi over 4. 37 pi over 4 is pi over 4 plus 36 pi over 4. That is equal to negative tan pi over 4 plus 9 pi. And we go back to the property from before, where if we have a, we add any multiple of pi to our tan, it takes us back to our original angle, we get negative tan of pi over 4, which is -1. And that's all she wrote today, guys.